Hey there, coding enthusiasts. Today, we're diving into object-oriented programming, or OOP for short. Let's start with the basics first. It is a way of organizing your code to make it more like the real world. Think about your backpack, your favorite toy, or your pet dog. Each of these objects has features, like the color of your backpack or the breed of your dog, and behaviors, like the backpack holding your books or the dog fetching a ball. In OOP, we use objects to represent these things in our code. In OOP, there are two main parts, classes and objects. A class is like a blueprint, it tells you what features, also called variables, and behaviors, also called functions or methods, an object will have. An object is like the actual thing you create based on that blueprint. For example, if you have a class called recipe, it can describe general features like the ingredients and cooking time, and behaviors like cooking and stirring. Then, you can create specific recipes from this class, like French fries, or chocolate cake as object of class recipe. Now, let's break down main ideas behind OOP. Encapsulation. Think of this like putting all the important things about an object in one place and keeping them safe. For example, your backpack holds your books, but you don't let everyone take out the books unless you allow it. In programming, encapsulation works the same way. It hides the details inside the object and only allows certain parts of the code to interact with it. It keeps the features, variables, safe, and the behaviors, functions, controlled. Encapsulation is achieved by using access modifiers, like private or protected, to restrict direct access to an object's internal features. Abstraction. Abstraction is similar to encapsulation, but it's more about simplifying things. It means you only show the necessary information and hide the complex details. For example, when you drive a car, you don't need to know how the engine works, you just use the steering wheel, the pedals, and the gear shift to control the car. In OOP, abstraction helps to show only the essential parts of an object's behavior, hiding the more complex logic behind the scenes. It helps you focus on what the object does, not how it does it. Encapsulation is like having a locked drawer where you keep your important things, and only you have the key. Abstraction is like not caring how the lock works, just using the key to open the drawer. Inheritance. Think of inheritance like traits being passed down from one generation to the next. If your parent is tall, you might inherit their height. In OOP, inheritance lets one class get the features and behaviors from another. For example, you have a class called animal, which has features like legs, and behaviors like breathe. Then, you can create a new class, like dog, which automatically gets those features and behaviors, but you can also add new traits like bark or fetch. Polymorphism. This is about using the same behavior in different ways. Imagine a remote control that can control different devices. When you press the power button, it can turn on the TV, the fan, or the air conditioner, depending on which device you're using. In OOP, polymorphism allows you to use the same method name, but the method does something different depending on the object. For example, the start method for a car might start the engine, while the same start method for a washing machine might start the washing cycle. Consider this example. Imagine a school's general blueprint. This blueprint defines the important things every school has: teachers, students, classes, affiliations, and timings. It's a broad plan for what a school is, but it doesn't have any specific details yet. This is just a class, like the skeleton that will define all schools. Now, let's take a specific school. This could be a happy school with a fun environment, or a strict school with lots of rules. These are different schools, but they're all objects created from the same blueprint of the school class. Each one is unique with its own features, like different teachers, rules, or schedules, but they all share some things in common because they are based on the same blueprint, class. In the same school some students feel excited while in same school some students feel trapped. Even though both students follow the same schedule, their experiences differ. This is polymorphism. The same action, attending class, can have different outcomes. In school, you don't need to know how the teacher plans lessons or arranges the timetable, you just focus on your class. This is encapsulation, hiding unnecessary details and showing only what's important. When you use an elevator, you don't care how it works, just press the button and go to your floor. Abstraction simplifies complex things, allowing you to interact only with what you need, without worrying about the details. A fun science school shares common features with a happy school, but adds extra things, like science labs. This is inheritance. New objects inherit features from old ones and can add their own. Thank you for watching.